Hello everyone, I'm Pragya Kaur and today I'll be presenting our paper Nosype, a novel nose-tip tracking-based text entry system for smartphone users with clinical disabilities for touch-based typing. Smartphone-based typing is an important and common practice nowadays for exchanging emails or text. Traditionally, QWERTY keyboards for touch-based text entry systems are used. Even though it is globally employed for its ease and speed, it is not quite suitable for people with clinical conditions like dactylitis, sarcopenia, etc. Modern solutions include gaze and head orientation-based typing or voice-to-text methods, which are contact-free and suitable for these specific users. However, they are affected by external noise or require commercial trackers. In this paper, we propose a novel touch-free text entry system for smartphones that uses the facial movement of the users in air, specifically their nose tip, to draw out characters on screens and select whole words in punctuation marks. This system allows free head movement and allows the user to draw the characters in any font, at any pace, and on any part of the screen. It also has features like auto conversion of cases, generation of auto suggestion lists, and sensor-based editing. Nosype contains a draw interface where the user draws out the character by moving their head, especially their nose tip, in front of the smartphone's front camera. This interface uses a dynamic canvas to capture the drawn characters from any part of the screen and an adaptive dwell time to allow the users to draw at their own paces. In the locate interface, the user can select suggested words based on the drawn characters or punctuation marks. The user can switch from this draw to locate interface for punctuations by simply shifting their facial area towards the soft activation button. Here's a depiction of how the interfaces look in Nosype. Nosype uses 68 facial landmarks based detection and tracking for nose tip, a convolutional neural network for predicting the drawn characters or numbers, a dictionary word order based suggestion generation, 6 facial landmark based nose tip projection, facial region overlap based activation of soft buttons, and finally an accelerometer reading based orientation tracking module. In the lab scale setup, Nosype has been tested with 11 participants with different medical conditions like sarcopenia, dactylitis, essential tremors, vertigo, and so on. Initially, they have been trained to use Nosype and other applications for the baseline comparison. In this study, the locate or the projection interface has been tested and compared with 4 other applications based on some other works. These applications either use eye gaze or touch-free finger projection for the selection of keys from soft keyboards. The participants use these applications in a Latin square-based task ordering and selecting each key on the soft keyboard for 5 times using each app. The system's performance has been tested by considering the accuracy of typing these characters and the shift between the actual and the predicted locations of these keys on screen. It was found that both for single sequence task ordering and Latin square method, Nosype's performance significantly dominated that of others with a typing accuracy of about 97%. Comparing the maximum, minimum, and average shift or error between the actual and predicted key coordinates, it was seen that for Nosype, the error was the least for all these cases. In the second study, the draw interface has been tested and compared with the 2 other applications. First is a traditional touch-based QWERTY keyboard, and the second is a VFP that uses finger projection to draw characters. Firstly, the participants selected 3 sentences from a corpus and typed those using the 3 applications with and without auto suggestions as fast as possible. This was to test the achievable typing speeds in these 3 apps. Secondly, they had to select 3 more sentences from the same corpus and then type them using the 3 applications without the auto suggestion feature at their own paces. This was to test the different matrices for estimating the typing errors. The average typing speed achieved by Nosype is 2.9 words per minute without auto suggestion and 6.31 words per minute with auto suggestion, which is more than the VFP, where the typing speed was 3.3 words per minute with auto suggestion, but was slightly less than the TBK method, where it was 8.9 words per minute with auto-suggestion. Different matrices, including the minimum string distance error, keystrokes required per character, etc., have been used to compare the performance of Nosype and other applications. For the study in the wild, 60 participants belonging to the age group of 23 to 90 years old were considered. 10 of them had medical conditions and were senior citizens. The participants were asked to use Nosype and type at least about 30 words to provide a feedback of the system based on the system usability scale. The average score received in this study was 77.7, and it was very interesting to find that the 10 participants with medical conditions scored between 75 to 87.5. Finally, to conclude, Nosype works well without mask with an accuracy of 93.61%. However, with mask, this accuracy decreases to 70.83% as of now. In future, we'll try to address this issue. But as of now, Nosype works significantly well for short messages and helps the target group of clinically challenged users. Thank you.